Welcome to Lecture 2, Why Software Architecture is Important. This is your Professor Atif Fareed Muhammad. There are 13 reasons. I will elaborate these 13 reasons so you know exactly why this is significant. An architecture will inhibit or enable a system's driving quality attributes. If you have a home with 3 bedrooms and a kitchen and that's it, the quality of life goes down the drain because there is no bathroom in that. Reason the architect did not have provision to put the bathroom in the house. That can be a studio apartment. It still will need a bathroom with a toilet and running water. That's the quality of life, or can be a quality attribute of a house. The decisions made in an architecture allow you to reason about and manage change as the system evolves. So when you're creating an office building, you make sure that there is a big hall, there are a few bathrooms, there are few storage facilities built in the office, there are passageways, there are conference rooms. What if there are no conference rooms? Would you be able to take a conference? You cannot. The analysis of an architecture enables early prediction of systems qualities. A document architecture enhances communication among stakeholders. When you write a document, if you do not put an index on first page or second page, let's say first page is title page, the second page is the index, and the rest of the document has all the stuff that you have written. If there is no index given, that quality attribute is missing from that. If the document is 63 pages, how would I know which part is what? Are there chapters, are there sections, and all that jazz? A document architecture enhances communication among stakeholders, so you can share only index and then people can just jump to their section or chapter and read that. It's exactly same thing as a book. The architecture is a carrier of the earliest and hence most fundamental, hardest to change design decisions. An architecture defines a set of constraints or subsequent implementation. The architecture dictates the structure of an organization or vice versa. You have a chief executive officer, you have chief operating officer, you have chief information officer, you have the vice president, you have the director, you have the manager, and then you have teams. An architecture can provide the basis of evolutionary prototyping. An architecture is the key artifact that allows the architect and project manager to reason about cost and schedule. An architecture can be created as a transferable, reusable model that form the heart of the product line. Architecture-based development focuses attention on the assembly of components rather than simply on their creation. By restricting design alternatives, architecture channels the creativity of developers, reducing design and system complexity. An architecture can be foundation for training of a new member. A system architecture has a starting point, then there are architectural decisions. For one decision can be manage change, the other can be predict system qualities, other can be enhanced communication, the other can be fundamental design decisions. These are all architecture design decisions. Manage change has system evolution, comes out of manage change, predicts system qualities, brings us to early prediction. Enhanced communication takes us to stakeholder communication between the teams. Fundamental design decisions takes us to hardest to change decisions. This is sort of an architecture. Inhibiting or enabling a system's quality attributes. Whether a system will be able to exhibit its desired or required quality attributes is substantially determined by its architecture. This is the most important message of this course. Performance, modifiability, security, scalability, incremental subset delivery, and reusability. In performance, you must manage the time-based behavior of elements, their use of shared resources, and the frequency and volume of intern element communication. Modifiability: assign responsibilities to elements so that the majority of the changes to the system will affect a small number of those elements. Security: can be manage and protect inter-element communications and control which elements are allowed to access which information. You may also need to introduce specialized elements such as authorization mechanism like identity and access management. When you join a university, you have to be assigned by the university your username and password and the multi-factor authentication to log in into your email, so you can use Canvas or any other thing associated. Scalability: localize the use of resources to facilitate introduction of higher capacity replacements, and you must avoid hard coding in resource assumptions or limits. Incremental subset delivery: manage intercomponent usage. You cannot simply just join the university and take all the courses at once. You have to go incrementally. Reusability comes in handy when restricting inter-element coupling, so that when you extract an element, it does not come out with too many attachments to its current environment. Let's look into this with a real use case of a university management system. In the realm of software architecture, much like entrepreneurial landscape, Peter Thiel is an author that has given us a few books, would tell you how to do it. I would suggest you to read his books. The pursuit of performance is paramount when you're dealing with software architecture design. Imagine a startup, let us call it 0 to 1 Software, that aims to disrupt the market with a revolutionary application. The architects at 0 to 1 understand that performance is not just speed, but also about efficiency and responsiveness. They design their system to handle high throughput and low latency, ensuring that users experience seamless interaction. This is akin to Peter Thiel's philosophy of creating monopoly in a niche market. By focusing on performance, 0 to 1 can outpace competitors and capture significant user base. Modifiability, security, and scalability are the pillars that support 0 to 1, our company or our startup, ambitious goals. The architecture is designed with modularity in mind, permitting for easy modifications and updates. The adaptability is crucial in a rapidly changing tech landscape. Much like how Peter Thiel advocates in his book 0 to 1, for companies to be flexible and ready to pivot. Security is integrated in every layer, protecting user data and ensuring trust, a non-negotiable aspect in today's digital world. Scalability is achieved through the microservices architecture, enabling the system to handle increased load without compromising performance. This approach mirrors Peter Thiel's advice on scaling businesses and start small, validate, and then scale exponentially. So I strongly suggest you to read that book, 0 to 1. Reasoning about and managing change. About 80% of a typical software system's total cost occurs after initial deployment. Accommodate new features, adapt to new environments, fix bugs, and so forth. Every architecture partitions possible changes into 3 categories. A local change can be accomplished by modifying a single element. A non-local change requires multiple element modifications but leaves the underlying architectural approach intact. An architectural change affects the fundamental ways in which the elements interact with each other and will probably require changes. Obviously, local changes are the most desirable. A good architecture is one in which the most common changes are local and hence easily be made. So the suggestion here, reasoning about and managing change, it is better to have UI, UX taken care. UI is user interface, and UX is pretty much a user experience. How would you do that? So let's continue with this. System architecture impact. If you look at that, we can see there is a start, architecture decisions, and as we have seen this pictorial representation earlier, we can see if there is a problem found early, it's cheaper and easier to fix the early prediction. However, the architectural decision that deals with predict system qualities can also lead us to the early prediction. That can also come from the architectural decisions leads to quality attributes associated with architectural designs decisions made and confidently predict, and that predicts system qualities for us, and then early prediction happens. That's how an architecture looks like when we are doing a software architecture. Enhancing communication among stakeholders. Now let's look into this within a university system as a storyline which can later be converted into an architecture. Enhancing communication among stakeholders is crucial in developing a university student management software, as it ensures that everyone involved, from developers and administrators to faculty and students, understands the project's goals, progress, and challenges. Effective communication fosters collaboration, aligns expectations, and helps in making informed decisions. By keeping all stakeholders in the loop, you can avoid misunderstandings and ensure that everyone is working towards the same objective, such as streamlining student registration, managing course schedules, and improving overall administrative efficiency. Clear communication channels, such as regular meetings, email updates, and collaboration tools, play a vital role in maintaining transparency and cohesion throughout the development process. One of the key strategies to enhance communication is the use of visual aids. Diagrams, flowcharts, and prototypes can help stakeholders understand complex architectural concepts more easily. For instance, a flowchart illustrating the student registration process can make it simpler to explain how different components of the system interact and how changes in one area like course selection might affect others, such as tuition calculation. This is especially useful for non-technical stakeholders like faculty and administrative staff who may struggle with technical jargons. By providing visual aids, you can bridge the gap between technical and non-technical stakeholders, ensuring that everyone has a clear understanding of the project's architecture and its impact on daily operations. Regular updates and feedback are essential for maintaining effective communication in the development of the university student management software. Keeping stakeholders informed about the project's progress through regular updates ensure that everyone is aware of the current status and any upcoming milestones, such as the launch of new feature for course enrollment. Encouraging feedback from all stakeholders helps in identifying issues early and making necessary adjustments. For example, students might provide valuable insights on the user interface, while administrators could offer suggestions on improving data management processes. This continuous dialogue fosters a collaborative environment where everyone feels valued and heard. Additionally, maintaining comprehensive and up-to-date documentation of software architecture serves as a reference point for all stakeholders, ensuring consistency and clarity in understanding how the system functions. Earliest design decisions. The software architecture is a manifestation of the earliest design decisions, as you have just seen in a real architecture diagram that I have added in the previous slides. These early bindings carry enormous weight with respect to the system's remaining development, its deployment, and its maintenance life. Each decision constrains the many decisions that follow. What are these early decisions? embodied by software architecture? Will the system run on one processor or be distributed across multiple processors? Will the software be layered? If so, how many layers will there be? What will each layer do or can do? Will components communicate synchronously or asynchronously? Will they interact by transferring control or data or both? Will the system depend on specific features of the operating system or the hardware? Will the information that flows through the system be encrypted or not? Multi-factor authentication is an example of that. What communication protocols will we choose? Imagine the nightmare of having to change any of these decisions once your software is appropriately done after the implementation of the architecture. Defining constraints on an implementation. I would skip the slide, rather I will read the example. An architect designs performance budget to the pieces of software involved in some large piece of functionality. If each software unit stays within its budget, the overall transaction will meet its performance requirement. Implementers of each of the constituent pieces may not know the overall budget, only their own. Let's look into this as an example. So if we go back to the university management system, inclusive meetings and transparent decision making are also critical for enhancing communication in the project, because communication is part of the budget. When we communicate with another individual, the other individual usually waits for us to finish our thing that we started telling him or her or somebody, and then responds in either a nod or a yes or no, or can ask for more explanation. So holding meetings that include all relevant stakeholders ensure that everyone has a chance to provide input and understand the decisions being made, as decisions have different constraints associated, whether the students are undergrad, whether the students are transfer students, whether the students are the graduate students. So these are all constraints which are associated when a student enrolls in a university system. Influencing the organizational structure. Architecture prescribes the structure of the system being developed. The structure becomes engraved in the structure of the development project and sometimes the structure of the entire organization. The architecture is typically used as the basis of the work breakdown structure. The work breakdown structure in turn dictates units of planning, scheduling, and budget. Who is doing what in terms of designing the software, whether this is a user interface, whether this is a database, whether this is communicating with another system. So payroll is communicating with finance. However, enrollment is communicating with the account receivables. Inter-team communication channels, configuration control and file system organization, integration and test plans and procedures, and much more. The maintenance activity will also reflect the software structure, with teams formed to maintain specific structural elements from the architecture. If these responsibilities have been formalized in a contractual relationship, changing responsibilities could become expensive or even litigious. Enabling evolutionary prototyping. Let's look into this with an example. Enabling evolutionary prototyping in software architecture is like building a Lego city. You start with a simple model and gradually add more details and features as you go along. Imagine a group of students working on a project to create a new mobile app for their department. They want the app to help students manage their homework, check their grades, and communicate with teachers or teaching assistants. Instead of trying to build the entire app at once, they decide to use evolutionary prototyping. The students begin with basic prototype that focuses on just one feature, the homework planner. They design a simple interface where students can add their assignments and set reminders. This initial prototype is not perfect, but it allows them to test the core idea and gather feedback from their classmates. They find out that works well and what needs improvement. For example, they might discover that students want to be able to categorize their assignments by subject or prioritize them by due dates. With this feedback, the students start adding new features and refining the existing ones. They introduce a grade tracker where students can input their grades and see their average in each subject. They also add a messaging system for students to communicate with their teachers. Each new feature is first tested as a prototype, permitting the team to make adjustments based on the user's feedback before fully integrating into the app. This iterative process ensures that the app evolves in a way that meets the needs of its users. As the project progresses, the students continue to gather feedback and make improvements. They might add the calendar view of the homework planner or a notification system to remind students of upcoming deadlines. They also work on improving the user interface to make the app more intuitive and user friendly. By using evolutionary prototyping, the students can gradually build a complex and functional app that truly meets the needs of their school community. This approach not only helps them to create better product but also teaches them the valuable lessons about collaboration, adaptability, and the importance of user feedback in software development. Improving cost and schedule estimates. Let's look into this with an example also. Improving cost and schedule estimates in software development is like planning a big departmental trip. You need to carefully consider that all the details to ensure everything goes smoothly and stays within the budget. Imagine a group of students who are part of their department's tech club. They have been tasked with developing a new website for the department, and they need to provide accurate estimates for how much it will cost and how long it will take. The students start by breaking down the project into smaller, manageable tasks. They list out all the features they want to include, such as homepage, a calendar for departmental events, a blog for departmental news, and a contact form. For each feature, they estimate how many hours it will take to design, develop, and test. They also consider any potential challenges or risks that might affect the timeline, like unexpected bugs or changes in requirements. Next, the students research the cost associated with each task. This includes not only the time spent by the team, but also any tools, software, or services they might need to purchase. For example, they might need to buy a domain name, hosting services, and design templates. They also factor in any additional costs like hiring a professional designer for complex graphics or paying for a project management tool to keep everything organized. With all this information, the students create a detailed project plan. They use tools like spreadsheets or project management software to track each task, its estimated time, and associated costs. They also build in some buffer time and extra budget to account for any unexpected issues. This way, they can provide a more accurate estimate to the school administration. As the project progresses, the students regularly review and update their estimates. They track their actual time and costs against the estimates and make adjustments for as needed. For example, if a task takes longer than expected, they might need to reallocate resources or adjust the timeline. By staying on top of their estimates and making data-driven decisions, the students can ensure that the project stays on track and within the budget. The students successfully launched a new departmental website and they learned valuable lessons about project management, cost estimation, and the importance of careful planning. Hopefully, this has been helpful. Transferable and reusable module. So, since we have looked at a departmental app that has the homeworks uploaded to be discussed between the students, and now a new professor comes in and asks them to add in the same app a presentation or slide deck add-on for the professor to look at while the students are working on top of that. That means transferable features which are already homework can be uploaded in the app. So presentation or slide deck can also be uploaded in the app. And reusable module or model, the same model that we have done for uploading the homework can be used for presentation upload as well. Using independently developed components, architecture-based development often focuses on components that are likely to have been developed separately, even independently from each other. The architecture defines the elements that can be incorporated into the system. Commercial off-the-shelf components, open source software, publicly available apps, and network services are examples of interchangeable software components. The payoff can be decreased time to market, increased reliability. Widely used software should have its bugs ironed out already. Lower cost. The software supplier can amortize development costs across their customer base. Flexibility. If the component you want to buy is not terribly special purpose, it is likely to be available from several sources. This increasing your buying leverage. So like Excel worksheet in Microsoft is equivalent to Google worksheet in the Google Cloud Platform or GCP. And same thing is applicable with the Word document, whereas Google Docs has a similar features for us to incorporate. Restricting design vocabulary. As useful architectural patterns are allocated, we see that the benefit in voluntarily restricting ourselves to a relatively small number of choices of elements and their interactions. We minimize the design complexity of the system we are building, enhanced reuse, more regular and simpler design that are more easily understood and communicated, more capable analysis, shorter selection time, greater interoperability. Architectural patterns guide the architect and focuses on the architect's quality attributes incorporation that the architect is actually working with. Properties of software design follow from the choice of an architectural pattern. The basis of training. The architecture can serve as the first introduction to the system for new project members. Module views are excellent for showing someone the structure of a project, who does what, which teams are assigned to which parts of the system, and so forth, as we discussed in the mobile app that we developed for the students earlier in Hypothetically. Component and connector views are excellent for explaining how the system is expected to work and accomplish their job, as you just have witnessed in the software architecture I have incorporated in the earlier slides. An architecture will inhibit or enable a system's driving quality attributes. The decisions made in an architecture allow you to reason about and manage change as the system evolves. The analysis of an architecture enables early prediction of a system's qualities. A documented architecture enhances communication among stakeholders. The architecture is a career of the earliest and hence most fundamental, hardest to change design decisions. An architecture defines a set of constraints or subsequent implementation. The architecture dictates the structure of an organization, vice versa. Hopefully, this lecture has given you something to understand in terms of software architecture and design decisions. I wish you best of luck in understanding, and let's finish by reading the next few pointers. An architecture can provide the basis for evolutionary prototyping. An architecture is the key artifact that allows the architect to project manager for reason about the cost and schedule, as we just discussed earlier. An architecture can be created as transferable, reusable model that form the heart of the product line. Architecture-based development focuses attention on the assembly of components rather than simply on their creation. So again, if this is a condominium architecture, a design that is happening, and there is no bathrooms given, but there is kitchen, there are closets and all that jazz. Would you like to go and live in that condominium or an apartment or a house? That house does not have bathrooms or running water. You will not. You would rather ask who's the architect of this building or dwelling. So by restricting design alternatives, architecture channels are the creative part for the developers, reducing design and system complexity. An architecture can be the foundation for training of the new team member. See you in the next lecture. Happy learning.